Is it possible to imagine a planet comprised completely of water? There are strange planets in the cosmos, ranging from planets that round their star in a few hours to planets with dusty tails like comets. But is it possible to imagine a world comprised completely of water? What does science have to say about it? Would the rules of physics permit the formation of a planet with no core and only water? Let us investigate. Hello everyone, welcome back to ZE. If you're new to the channel, don't forget to hit that subscribe button and turn on the notification bell so you never miss an update. Without further ado, here are some of the exoplanets that could be totally formed of water. Kepler-62e and Kepler-62f. These two planets, which orbit the star Kepler-62, are intriguing because they are in the habitable zone of their star, which implies they may have liquid water on their surfaces. Kepler-62e is the closest planet to the star and is roughly the size of Earth, although its surface temperature is approximately 0 degrees Celsius. This makes it extremely cold in comparison to Earth, but yet within the range where liquid water may exist. Kepler-62f, on the other hand, has a slightly colder surface temperature of around -40 degrees Celsius. What makes Kepler-62e and Kepler-62f even more intriguing is that their sizes and masses are similar to Earth's, implying that they may share an interior structure and possibly a life-supporting atmosphere. However, whether or not these planets have liquid water on their surfaces has yet to be established. Kepler-62 is also fascinating since it is a dwarf star like the Sun, which implies it has a considerably longer lifetime than the most famous and brightest stars. This means Kepler-62 and its planets have the potential to survive for billions of years, giving them plenty of opportunity to develop and evolve. It should be noted that the hunt for habitable planets is a very busy field in astronomy. Exoplanets with liquid water on their surfaces are being discovered at an increasing rate, implying that there may be many more habitable planets out there waiting to be discovered. Kepler-62e and Kepler-62f are interesting planets that may have liquid water and maybe life on their surfaces. We may uncover more planets like these as exoplanet detection technology and procedures improve, allowing us to explore and learn more about the possibilities of life elsewhere in the universe. Kepler-62e and Kepler-62f, in addition to possibly habitable features, contain some intriguing mysteries and anomalies. These planets, for example, are thought to have extremely lengthy days. They are gravitationally locked because they are so close to their star, which means they always exhibit the same face to it. This means that one half of the planet is always lit, while the other is always dark. In terms of composition, both exoplanets are thought to be a combination of rock and water. Some scientists believe these planets could be coated in a 500-kilometer thick layer of water. Could you imagine? To put this in perspective, the deepest part of the ocean on Earth is the Challenger Deep, which is only 11 kilometers deep. It is nothing in contrast. The notion that these exoplanets contain such a thick coating of water is based on density measurements, since water is the only component that fits the chemical properties measured on these two worlds. Trappist1e and Trappist1f. Trappist-1 is a star system 39 light-years from Earth that is made up of an ultra-cool dwarf star and 7 planets, 3 of which are in the system's habitable zone. Trappist-1e and Trappist-1f have been identified as promising candidates for the hunt for life. Trappist-1e is the 4th planet from its star, and it is roughly the same size as Earth. It is in the system's habitable zone, which suggests that its surface temperature might support the presence of liquid water. However, due to its star's proximity, Trappist-1e is thought to be gravitationally anchored, which means that one side of the planet always points to its star. The planet's surface might become very hostile, with temperatures ranging from -40 degrees Celsius to 106 degrees Celsius. Trappist-1f, on the other hand, is the 5th planet in order of distance from its star and is likewise in the system's habitable zone. It is slightly larger than Earth and is thought to have a thick atmosphere composed primarily of hydrogen gas. Trappist1e, despite being in the habitable zone, is thought to receive 30% less light from its star than Earth does from the Sun, implying that it may be too cold for life as we know it. The fact that Trappist1e and Trappist1f are in a highly compact planetary system is one of the most interesting elements of them. The planets are so close that if you were on the surface of one of them, you could view the other planets as brilliant, nearby worlds. Tidal currents may also stir up the atmospheres of the planets due to their proximity, which may alter habitability. The hunt for life in Trappist1e and Trappist1f is a critical topic in astrobiology. The availability of liquid water on a planet's surface is thought to be one of the key criteria for life as we know it, and Trappist1e and Trappist1f are two of the best chances. Scientists are developing new telescope technology to investigate these atmospheres and determine whether these planets have evidence of life. HD 219134b. HD 219134b is a Neptune-sized exoplanet that orbits the neighboring star HD 219134, which is only 21 light-years away from Earth. It was identified in 2015 by the Kepler Space Telescope and has piqued the interest of astronomers ever since due to its potential to house water and other life-sustaining molecules. One of the most intriguing aspects of HD 219134b is its close proximity to Earth. In comparison to many other exoplanets, this one is relatively close to our solar system, making it an appealing target for space exploration and research. Its proximity also allows astronomers to better analyze its features and composition. Another intriguing feature of HD 219134b is its orbit. The exoplanet completes one cycle around its star in just 3 Earth days, implying that its year is only 3 days long. Because of its close orbit, the exoplanet is thought to have an extraordinarily hot surface temperature, possibly exceeding 700 degrees Celsius. Despite its tremendous temperature, HD 219134b is thought to have a thick atmosphere that might host liquid water. The atmosphere of HD 219134b was studied using spectroscopy by astronomers. This method examines the light that travels through the atmosphere of an exoplanet as it orbits its star. According to the data acquired, the exoplanet's atmosphere is mostly made of hydrogen and helium with trace amounts of water vapor and carbon dioxide. These findings have led astronomers to suggest that HD 219134b may contain a Neptune-like atmosphere, with an upper layer of hydrogen and helium and a lower layer rich in water and other chemicals. But maybe the most important aspect of HD 219134b is the possibility of life on its moons. Even though the exoplanet's surface is extremely unfriendly due to its high temperature, some of its moons may have more hospitable conditions. According to certain hypotheses, the moons of exoplanets like HD 219134b may be more habitable than the planets. GJ1214c. GJ1214c is a super-Earth exoplanet that orbits the red dwarf GJ1214 in the constellation Ophiuchus, approximately 40 light-years away from Earth. The Hubble Space Telescope detected it in 2009. Because of the presence of a rich atmosphere and the possibility of water on its surface, it is considered one of the most promising exoplanets for the hunt for life. The exoplanet has a mass around 6.5 times that of Earth and a radius of 2.7 times that of Earth. GJ1214c is thought to be made up of a rocky core and an atmosphere rich in water and volatile gases like hydrogen and helium due to its size and density. Its average surface temperature is predicted to be roughly 232 degrees Celsius, making it too hot for life as we know it. Although GJ1214c is thought to be an exoplanet formed completely of water, its internal structure is unclear due to a lack of data. According to certain studies, it may have a worldwide ocean with a depth of up to 200 kilometers. Furthermore, the exoplanet's dense atmosphere may protect its surface from UV radiation and water evaporation. Because of the existence of water vapor in its atmosphere, the dense atmosphere of this exoplanet has also been examined. Light absorption in the atmosphere of the Hubble Space Telescope has been found, confirming the existence of water vapor. Furthermore, the spectrum of light traveling through its atmosphere indicates the presence of other chemicals like methane and carbon dioxide. The examination of GJ1214c's atmosphere has caused scientists to question the feasibility of life on this exoplanet. Although the surface of the exoplanet is too hot to host life as we know it, some research suggests that there may be life forms that can adapt to the severe conditions of its atmosphere and ocean. This is the closest to being fully formed of water of any planet discussed thus far, but as we can see, its composition is still unknown. As a result, we must ask ourselves, is it practically possible to imagine a planet comprised completely of water? The answer is yes, that planet exists, and it's known as Gliese 1214b. Gliese 1214b is an exoplanet found by the Hubble Space Telescope in 2009. This planet is roughly 40 light-years away in the constellation Ophiuchus. One of the most intriguing aspects of Gliese 1214b is that it is thought to be a water-only planet. This planet orbits its star relatively near, only 1.5 million kilometers distant, completing one orbit in 1.5 Earth days. The planet is continually subjected to high temperatures due to its proximity to the star. Regardless, the pressure on the planet's surface is so tremendous that the water is thought to be in an exotic form known as superionic water. Superionic water is a state of matter observed at high temperatures and pressures. The hydrogen in the water ionizes and becomes an electrical conductor in this state, while the oxygen stays liquid. As a result, superionic water is a superb electrical conductor and an exceptional material. Gliese 1214b's discovery has raised many questions and speculations concerning the likelihood of life on water worlds. Although this planet is not habitable due to its closeness to its star and extremely high temperatures, its discovery has led to the hypothesis that there may be more habitable planets in other star systems. Another intriguing detail of Gliese 1214b is the presence of water vapor in its atmosphere. This discovery has led to speculation that other comparable planets may have water-rich atmospheres, indicating the presence of life. Furthermore, examining the atmosphere of this planet has improved our understanding of how planetary atmospheres interact with their stars. This planet is thought to have originated from ice and dust that gathered around its star during the planetary system's development. The heat from the star melted the ice as the planet formed and traveled closer to its star, converting it to water. This process is critical because water planets are thought common in the galaxy and may be crucial life forms. Water is thought to be a necessary component of life as we know it, and water planets may be the only means for life to exist elsewhere in the cosmos. Each of the exoplanets mentioned above has distinct properties, ranging from the ability to support life to the likelihood that they are entirely formed of water. These discoveries are just a taste of what is possible in the study of space and the universe. The search for exoplanets and the discovery of the universe propel us forward and encourage us to keep exploring and learning. This quest may appear enormous, yet each discovery, technological advancement, and new theory takes us closer to comprehending the universe and our place in it. Alright everyone, here's where the video ends. Thanks for watching. If you found this content valuable, please consider giving it a thumbs up and leaving a comment below. Your feedback is incredibly important to us, and we love hearing from all of you.